Right now, far beyond Earth, there's a telescope floating in deep space. It sits nearly 1,000,000 miles away, in the quiet darkness beyond the moon. And it is staring into the past. Not hours into the past. Not centuries. Billions of years. This machine is the James Webb Space Telescope, the most powerful space observatory ever built. And what it's seeing is rewriting our understanding of the universe. Today, we're going to step back, farther and farther, until we reach a scale the human brain was never meant to comprehend. The true scale of the universe. Our starting point, Earth. Let's begin somewhere familiar. Earth. A rocky planet about 12,742 kilometers across. Covered in oceans, mountains, forests, deserts. To us, it feels enormous. But zoom out. Just a little. The Sun. Earth orbits a star, the Sun. It's about 150 million kilometers away. And the Sun is so large that over 1 million Earths could fit inside it. Yet even the Sun is small compared with many stars in our galaxy. Still, the Sun dominates our entire solar system. The solar system. If we keep zooming outward, we pass Mars. Then the gas giants Jupiter and Saturn. Then Uranus and Neptune. The outer edge of the planetary region lies billions of kilometers away. But beyond that is a vast cloud of icy debris, the distant Oort cloud. Even that enormous structure is still part of our Sun's gravitational influence. And yet, we still haven't reached the nearest star. The nearest star. The closest star beyond the Sun is Proxima Centauri. Distance: 4.24 light-years. A light-year is the distance light travels in 1 year, about 9.46 trillion kilometers. Light itself moves at 299,792 kilometers per second. And even at that incredible speed, it takes more than 4 years to reach the nearest star. If we sent the fastest human spacecraft ever launched toward Proxima Centauri, the trip would take thousands of years. We haven't even left our cosmic neighborhood. Our galaxy. Now zoom out further. Far beyond nearby stars. We find ourselves inside a vast spiral structure. The Milky Way. This galaxy stretches roughly 100,000 light-years across. Inside it are hundreds of billions of stars. And our Sun. Just one ordinary star among them. Located about 26,000 light-years from the center. At the heart of the Milky Way lies a massive object. The Sagittarius A star. It has about 4 million times the mass of the Sun. JWST has been studying the region around it. Watching infrared flares from hot gas swirling near the black hole. Even here, in our own galaxy, mysteries remain. Neighboring galaxies. But the Milky Way isn't alone. Our nearest large galactic neighbor is Andromeda Galaxy. Distance: 2.5 million light-years. That means the light entering your eyes from Andromeda tonight began its journey before humans even existed. And in about 4.5 billion years, the Milky Way and Andromeda will merge into a single giant galaxy. But this is still just a tiny corner of the universe. The observable universe. Astronomers estimate the observable universe may contain hundreds of billions, possibly trillions, of galaxies. Each galaxy contains billions of stars. Each star may host planets. And many of those planets could have environments we haven't even imagined yet. But JWST isn't just counting galaxies. It's finding very old ones. Older than we expected. Webb looking back in time. When JWST looks at distant galaxies, it isn't seeing them as they are today. It's seeing them as they were when their light first left. Because light takes time to travel. Some galaxies JWST observes are more than 13 billion light-years away. meaning we see them when the universe was extremely young. Only a few 100 million years after the Big Bang. A galaxy that shouldn't exist. One of the most surprising discoveries is the galaxy candidate, Jades GSZ140. This galaxy existed when the universe was only about 290 million years old. That's roughly 2% of the universe's current age. Yet it already appears large and bright, possibly containing heavy elements produced by earlier generations of stars. Which raises a big question. How did galaxies grow so quickly after the Big Bang? We're still trying to understand why JWST can see so far. The reason Webb can make these discoveries is simple. It sees infrared light. As the universe expands, light traveling across billions of years becomes stretched. Visible light shifts into the infrared. Older telescopes struggled to detect it. But JWST was built specifically for that purpose. Its 6.5-meter mirror, made of 18 gold-coated segments, collects faint infrared light from extremely distant galaxies. And its location, the Sun, Earth L2, keeps it cold and stable. Perfect for observing the faintest signals in the cosmos. A universe full of surprises. Every time JWST looks deeper into space, it seems to find something unexpected. Galaxies forming earlier than predicted. Black holes growing faster than expected. Complex molecules appearing in places we didn't anticipate. Each discovery tells us something important. Our models of the universe are improving. But they're not complete. And that's exactly what makes science exciting. The true scale. Now step back one more time. You are standing on a small planet, orbiting a medium-sized star, inside one spiral galaxy, among billions of galaxies in the observable universe, which itself spans roughly 93 billion light-years across. And that may not even be the full universe. Just the part we can see. The bigger question. When we look up at the night sky, we aren't just seeing stars. We're seeing history. Light that traveled across billions of years to reach us. Messages from the ancient universe. And JWST is reading those messages better than any telescope before it. Closing. We built a machine. Sent it 1,000,000 miles into space. And pointed it into the darkness. And the darkness answered. It's filled with galaxies. Black holes. Chemistry. And mysteries we're only beginning to understand. If this journey through the universe blew your mind even a little, you're in the right place. Curious Atlas exists to explore the biggest ideas in science, and make them feel real. Subscribe. And comment. Which JWST discovery fascinates you the most? Because the universe is far stranger than we imagined. And we've only just begun exploring it.